Hello, today I will solve IMO 2017 problem 3, which was one of the hardest problems in the history of the IMO because only two contestants will be able to solve this problem fully and get 7 points. This may be triggered by the fact that the second problem was a6 function, which can't be solved in a minute, and most of the contestants will have only half an hour to think about this problem. In this problem, we are given Hunter and Rabbit, which are in the same positions in the beginning of the game, and Hunter's aim is to keep the distance between him and Rabbit needs to get away from Hunter. Every minute, Rabbit can go to the distance from the previous distance by 1. Length of an minus 1 must be 1, and Hunter will be given an information p of n, which will be the coordinate of the point which is at most one distance from the Rabbit's initial coordinate, like Pn times an. This must be less or equal to 1. And then Hunter makes the optimal move to keep the distance. And the question is that, is it always possible for the Hunter to keep the distance lower than 100 centimeters or meters? It has no matter for us. And the answer in this problem is that Hunter can't make these moves. And the main idea in this problem is about the lemma. Like if at some point distance between Hunter and Rabbit is d, after some finite number of operations, Rabbit can increase this distance to square root d squared plus 1 over 2. And what will be this n? We will see that this number will be always enough for 400. Now look at, take any point, 2 points which are n distance from R, call this x and y, and take their perpendicular bisector. This line L will be their perpendicular bisector, and call this point K. Kx equals Ky and equals 1, and length of Rx equals length of Ry, and this is n. Clearly, Rabbit can get to point y or x in n minutes. And if the Hunter will be some point here after n minutes, we need to compute what will be the distance of hy and hx. At first, notice that the optimal move for Hunter would be to take as possible minimum of maximum of hx and hy. This would be the optimal move for the Hunter to keep the distance as minimum as possible for every variance of the Hunter's move. So Hunter must be on this line, on L line always. And now compute what will be hy, or we can call this h prime. At first, notice that yk equals 1 and ry equals n. So rk would be square root from n squared minus 1. And clearly this number is more than n minus 1 over n. And what can be said about the RH prime? This would be n minus d. So if you want to compute h prime y would be h prime y squared would be h prime k squared plus k y squared. Clearly this is n minus 1 over n minus n minus d, this into square, plus 1 square. And clearly this equals d minus 1 over n square plus 1. And this would be more than d square plus 1 over 2 if n is more than 4 times d. And why I have taken 400 here is that if at some point distance between the rabbit and the hunter became 100, then it will at least remain same. So if d is 100 or less number, then if we take instead of n 400, we will have that the distance will be increased by the square root d square plus 1 over 2. Okay, and now in the initial position, distance between hunter and rabbit was 0. And if we apply this lemma, 400, this is for one operation, times 2 times, because we need to add 1 over 2 to 1, and 100 square times, if this number is less than 10 to the 9, this means that in this moves, at most this number of moves, the distance between the rabbit and the hunter will be more than 100, more or equal to 100. And clearly, this number equals like 8 to the 6, 9 to the 6, and this is less than 9 to the 8. So in 8 million moves, in at most 8 million moves, we can make the distance between hunter and rabbit more or equal to 100. And clearly, we have shown that a rabbit will be always get out of the radius of the 100 from the hunter's point. And this was all what we wanted to show in the problem. If you want to discuss some difficult problems, please write it in the comments. And if you got any questions about these solutions, also write this in the comments. And don't forget to like and subscribe my videos.